1.7 linear inequalities preparation. Now we are dealing with union. Okay, now union is a bit different in that union includes everything in both sets. So for instance, let's say we have a 1, 2, 3, 4, 6. Okay. Now, we want to include everything both in A, which is over here, right? We want to include everything in A, but also, at the same time, we want to include everything over here with the B's, right? And that's called a union, or both are going to include everything, okay? So in this case, we're going to include the 1, 2, 3, 4, and 6. We're going to include everything, okay? And you don't have to repeat it, though, right? So if I write it that way, I'm going to only want to write each element once because I only want to include each element once, right? Okay, so if I ask you what elements are in the set, you don't need to repeat. That would actually be considered incorrect. Okay, so I get the fact that 2 kind of pops up twice, but we're not going to list it twice. If 2 is one of the elements, then 2 is one of the elements. You don't need to list it twice. Okay, so let's see what this looks like when we're dealing with an inequality. So, first step is you are going to solve the inequalities separately and then graph them separately. So what do? I would get the 6x by itself by undoing the subtraction of 4 by adding 4. And whatever you do to one side, you do to the other. Those cancel out, leaving me 6x is less than 2x plus 4. Next, I want to get all the x's on the one side, so I subtract 2x from the right. Those cancel out, leaving me 6x minus 2x is 4x less than 4. Next, I want to get the x by itself, so I undo the multiplication of x by 4 by dividing by 4. And whatever I do to one side, I do to the other, giving me x is less than 1. And then I plot the 1. And then since x is less than 1, I would do the parenthesis and then shade all this in here. There we go. Okay, so we finished the first one, so now we're going to do the second one. And because we're multiplying the x by the negative 3, so to undo the multiplication, you divide by negative 3, and whatever you do to one side, you do to the other. Gives me x is not less than, but greater than or equal to negative 9 divided by negative 3 is a positive 3. We plot the positive 3. And because x is greater than or equal to 3, we're going to use a bracket, and that's going to open up towards the right. Go all the way to infinity. Now, because we are doing a union or situation, we want to include everything that we can, as much as possible. So, in this case, we're going to include all of the red, which gives us the negative infinity to 1, both in parentheses. And I'm going to use the union symbol, and then I'm going to go over to bracket, and that is going to be a positive 3 to infinity, and then with a parenthesis at the end. Because it's understood if it goes off to the right forever, there's a positive infinity over there. Okay. So let's try another one. Okay, so we're going to solve negative 4x plus 1. We're going to get the negative 4x by itself by undoing the addition of 1 by subtracting 1. And whatever we do to one side, we do to the other. It gives me negative 4x is greater than or equal to 9 minus 1 or 8. Then we undo the multiplication of x by negative 4 by dividing by negative 4. And that gives me x is, now since I divided both sides by a negative 4, I need to flip it to less than or equal to, and 8 divided by negative 4 is negative 2. We plot the negative 2 over here. And then from there, because x is less than or equal to negative 2, the equal part's going to make this a bracket, and then we're going to shade in everything to the left. And we understand that over to the left we have a negative infinity. Okay. So we finished graphing the first one. Now we graph the second one separately. Okay. We have 5x plus 3. We want to get the 5x by itself. So we undo the addition of 3 by subtracting 3. Whatever we do to one side, we do to the other. Cancel, leaving us 5x is less than or equal to negative 12 minus 3, which is negative 15. Now we undo the multiplication of x by 5 by dividing by 5. And whatever we do to one side, we do to the other. Leaving me x is equal to negative 15 divided by 5, positive 5. Is going to give me a negative 3. Now we plot the negative 3 over here. And it says that x is a less than or equal to the negative 3. Okay, so we know we're going to have less than, which is to the left. It's going to open up to the left. We have the equal part, so this is going to be another bracket. Let me just shade that in. But because we have a union situation, we want to include everything. So we're going to include all the way the furthest to the left that we have right there, which is that negative infinity. So we have that negative infinity. And we're going to go all the way as far as we can right with the stuff that's shaded in, which includes all the way to negative 2. Negative 2 is going to have a bracket, and the negative infinity is going to have the parentheses. Let's try another one. Okay, so we have to solve each equation separately. So first we have a negative 2x plus 5 is greater than or equal to 11. We need to get the negative 2x by itself by undoing the addition of 5 by subtracting 5. Whatever you do to one side, you do to the other. It gives me negative 2x is greater than or equal to 11 minus 5, which is a 6. Then we undo the multiplication of x by a negative 2 by dividing by negative 2, and whatever we do to one side, we do to the other. And that leaves me x is less than or equal to 6 divided by negative 2 is negative 3. Next, we have 4x. Well, first let's finish graphing this. Negative 3 is going to be over here. We plot the point. X is less than or equal to negative 3. Because of the equal part, we are going to have a bracket. There we go. We understand that way over here to the left is a negative infinity. And that's it. So let's move on to the other equation. So we have 4x minus 7 is greater than or equal to negative 27. So we add 7 to each side. These cancel out, leaving me 4x is greater than or equal to negative 27 plus 7 is negative 20. We undo the multiplication of 4x by dividing by 4x. And whatever we do to one side, we do to the other. And that leaves me x is greater than or equal to negative 20 divided by 4 is negative 5. So now we plot the negative 5, which is over here. It says it's greater than or equal, which means it's going to be greater than to the right. The equal part's going to make it a bracket, and we shade it in, and it goes on forever to the right. And there's an understood positive infinity over there. Now remember, we want to include everything that's shaded in, either in the first equation or the second equation. And that looks like everything is shaded in. Since everything is shaded in, you're going to have a negative infinity to a positive infinity, with parentheses next to both. There you go.